Hello and welcome to the last exercise on chapter 5, and we're going to be integrating some trig functions today, but before we do we need to have a quick look at our basic rules. Now these are the things that you're going to have to learn and know them off by heart. So you can refer to them as you're going through the questions because they're on your booklet, but make sure that you learn these as you go. The integral of cos is sine. The integral of sine is negative cos, and the integral of sec squared is tan. So we need to memorize those, but they're not always quite that simple. Sometimes the angle is not just x. So this is a way we can memorize them. Now this is not quite the same way as it's written on your booklets. This is probably a little bit more powerful yet again. So see if you understand what we're talking about. I said the integral of cos was sine. So we've got the integral of cos is sine. But when you have some strange angle, the integral of cos is the sine of that strange angle, but then you need to divide by the derivative, not the integral, the derivative of the angle. And that same process happens repeatedly. When you integrate sine, the integral is minus cos, the angle doesn't change, but then you divide by the derivative, not the integral, the derivative of the angle. And finally, the integral of sec squared is tan, and the angle doesn't change, and you divide by the derivative of the angle. So let's try some questions. Here's our first one. What was the integral of sine? The integral, oh, went one too far there. Okay, what was the integral of sine? The integral of sine is equal to minus cos. So the integral of sine is minus cos x plus c. And we're finished. That's it. Let's try part B, example 1b. We know the integral of sec squared is tan. So the integral of 3 sec squared will equal 3 tan x plus c. Finished. That's all there is to it. When you know the rules, you just follow them, and there's your answers. Example 1, part C. Now we're upping the level of difficulty just a little bit because our angle is not just an x. So remember, the integral of cos is sine. So we can write down the sine of our angle. The angle never changes. But we divide by the derivative of the angle. Now the derivative of 3x take 1 is 3. And then we put our plus c on the end. And that's how it works. Now remember, that's the same as this. 1/3 of the sine of 3x take 1 plus c. So either answer is acceptable, and when you're checking answers in the back of the textbook, be aware that both of those answers are the same thing. Let's try 1 part D. Now, this time we're integrating negative sine 4x. What's the integral of sine? Well, the integral of sine is minus cos. Now there's a minus sign already there in the question. So there's our minus sign from the question, and the integral is minus cos. The angle never changes. Over the derivative of the angle, the derivative of 4x is 4. And we put our plus c on the end. And obviously those two minuses I didn't really need to write. So the answer's the cos of 4x over 4 plus c, or as another option I could have written 1/4 cos 4x plus c. Right, example 2. Now we're going to do some questions where we have numbers on the integral signs, some terminal values. So this is fine. We're integrating from 0 through to pi sine x dx. Now what's the integral of sine? The integral of sine is minus cos. So the integral of sine x is minus cos x, and we're integrating from 0 to pi. So that becomes negative cos pi, because remember we're putting in pi everywhere we see x first, minus, now everywhere we see x we're putting in 0, minus cos 0. Many ways you can do this. You can convert pi to 180, do it on your calculator, or I'm going to just do it this way. I know a cos graph looks like this, and the cos of pi is minus 1. So that's minus 1. Take away the cos of 0 is plus 1. So it'll be minus 1, which will become 1 plus 1, which is 2. So there's our integral. Let's try part B. Now for part B, we're integrating the cos of 3x. So the integral of cos is minus. Let's backtrack there. The integral of cos is sine, not minus. The integral of cos is the sine of 3x. The angle never changes, but we're going to divide by the derivative of 3x, which is 3. And we're integrating from 0 to pi on 2. Now that will become the sine of 3 pi on 2 all over 3 minus the sine of 0 all over 3, because everywhere we see x, in the first situation I'm plugging in pi on 2 for the first bracket, and for the second bracket where I see x I'm putting in a 0. Now what's the sine of 3 pi on 2? 3 pi on 2 is there, halfway between pi and 2 pi, and it's minus 1. So that becomes minus 1 on 3. You could have done the sine of 3 pi on 2 on your calculator as well, or you could have converted it to degrees and tried doing it that way. The sine of 0 we know is 0, so the answer is minus 1/3. Let's try 2 part C. Now, 2 part C, the integral of sec squared is tan. No tricky parts with this one. Tan x, and we're integrating from pi on 6 to pi on 3. So that's going to become the tan of pi on 3 minus the tan of pi on 6. Now I don't like drawing tan waves as much, so I'm going to do this question by converting pi on 3 into degrees. Pi on 3, 180 on 3 is 60 degrees, minus pi on 6, 180 on 6 is 30 degrees. If I draw my triangle, 60, 30, 1, 2, root 3. The tan of 60, tan equals opposite on hypotenuse is root 3 on 1, which is just root 3, minus the tan of 30, opposite on adjacent. I think I said hypotenuse for the other one, but it's opposite on adjacent, which is 1 on root 3. Now that's your answer. However, often with questions like this, it will take it a bit further by getting a common denominator. So for a question like this, the first thing we do for the third part is rationalize the denominator, which means we would end up with root 3 minus root 3 over 3, because 1 times root 3 looking here, 1 times root 3 on the top is root 3, and root 3 times root 3 is 3, or root 3 times root 3 is root 9, and the square root of 9 we know is 3. If I combine those, the first part times top and bottom by 3, then I get a common denominator of 3. On the top of each fraction I've got 3 square root 3 minus 1 square root 3, which is 2 square root 3. So that's how we actually merge the answers together. So let's try finding the area between the curve y equals sec squared, x on 4, the x-axis and the lines x equals pi on 4 and x equals pi on 2. Normally this might be a problem because when you're finding the area under a curve, if it's below the x-axis we get a negative answer. If it's above the x-axis we get a positive answer. However, with this particular question, it's not an issue at all because the sec value is squared, and whenever you square anything you get a positive answer. So I don't have to worry about looking underneath the x-axis for this graph because sec of x on 4 is squared, and squareds are positive. So how do you find the area? Well, the area equals the integral from a to b y dx. What's a and b? So we've got the integral from pi on 4 through to pi on 2 of sec squared x on 4 dx. Now we know the integral of sec squared is tan. You get tan x on 4. But when you're integrating, if there is an angle other than x, you've got to also divide by the derivative of the angle. Now the derivative of 1x over 4 is 1 over 4. And it's from pi on 4 through to pi on 2. Now remember, that's like a 1 out the front and a quarter goes into 1 4 times. We could tidy that up and write it as 4 tan x on 4 from pi on 4 to pi on 2. Now what will that actually equal? Well, that becomes 4 tan pi on 2 gets plugged into x, so it becomes pi on 2 all over 4, which is the same as pi on 2 divided by 4, which is the same as pi on 2 times a quarter, which is pi on 8. And if we knew that straight away, we wouldn't have had to have written that down. We just can write it straight away because we know that. So pi on 2 on pi on 4 becomes pi on 8 minus 4 tan. Pi on 4 goes in for x. Pi on 4 becomes pi on 16. This is where you use your calculator. So I turn my calculator on. First double check that I am in radians mode. And I go 4 tan pi over 8, I'm typing it into my calculator at the moment, minus 4 tan pi over 16, close my bracket, equals, and I get 0.8612. That'll do to 4 decimal places, units squared, because it's an area. Okay, let's try example 4. And this is where we have to try and find a volume. Now remember, with the formula for volume, it is volume equals pi. integral from a to b y squared dx, which will equal pi, the integral from 0 to pi on 4 for this question. Y squared, well, I can see what y is. Y squared will equal sec x squared, which is sec squared x. Sec squared x dx. Now, the integral of sec squared is tan, and the angle is just x, so that's nice. From 0 to pi on 4, which becomes pi. Now, x is replaced with pi on 4. Now x is replaced with 0, which becomes pi. Now the tan of pi on 4 is a tan of 45, which is 1. The tan of 0 is 0. Try it on your calculator. So you end up with pi units cubed, because it's a volume. And there we have it. That's integration. Have a bit of fun. I shall see you later on. If you do have questions, you can see me later today. I should be back about recess time.